Hello friends, welcome back to the Dr. Tristos channel. I'm Dr. Tristos, happy to have you along. We posted on Facebook that TRS-NET is ready to be used, or at least start testing and finding out what we need to improve and fix, etc. I wanted to show you how that you can get your own copy and install it. That's what this video is about. And so the TRS-NET comes from my website, and let me get a browser up here and I'll go over with you just so we cover that. It's www.daniel, if I can type, paulmartin.com. And if we go to this website on my slow internet, we will see on the left hand side that we have different options here. My Tristos, TRS-NET, TRS-OS, etc. Work is here under my research. But to go directly to get the download, TRS-OS is nicknamed Squirrel. Maybe that's because it's squirrely, but there might be other reasons too. So you can click on download, and this will download an entire zip folder file with TRS-OS, the current version Squirrel of TRS-OS, and TRS-NET, along with a data file of blank or with sample files of disk images. So let's pretend that we clicked on that, because every installation is going to be different. If you download this folder, depending on which computer you're using or where it puts your downloads, what you will want to do is go to your download folder, get that zip file called TRS-NET with a hyphen in there. It's a zip file. You want to put that on your desktop. Now this installation process is very complex, and pay attention, because it's, I tried to make it simple, but it's pretty complex. Put the zip file on your desktop, then right click and click on Extract All. It will want to know where you want to place the contents, and I leave it on the desktop in a folder called TRS-NET. That's what it does by default right here. Extract. I already have a copy on there, so we're just going to, okay? So after you do that, you will now have a folder called TRS-NET on your desktop. At this point, congratulations, you have now installed TRS-NET on your PC. I hope this was not too difficult. But let's look at what was in that folder. We have a Python file called TRS-NET. This is the application you'll run on your PC. We have a TRS-OS Squirrel, and this is the file that you will use on your Agon or your Circle M hardware or other hardware that the loader loads into memory. So whichever platform, a development board, or whatever platform you're using, and you currently load a binary file, this is your new binary. This is your application that will be running on your PC. We can take a quick look at it. If anybody makes any smart remarks about my Python programming, I'll ban you for life. I'm joking. But I never wrote any Python code, really. I read Python for Dummies, and I wrote this application. So it is what it is, but it does the job. And I do want to point out that I also made this so that The CPM based systems, we could also write drivers for CPM and share the same files on a PC. I realize they have different record links and things, but we could fix that. And this one server program could work for more than one different platforms. And the advantage to that would be that so they could read and write the same data and binary files all in one folder. That could have advantages. Maybe you have a CPM system and you want to store documents and you want to be able to read those with TRS-NET. So we're going to we pulled this up. We didn't have to open that with idle for editing. We could have just clicked directly on TRS-NET and it should execute, open up and execute. You need to have Python installed on your PC. You don't really need to know anything about it. Let's say it's similar to in the old days of having BASIC installed was on every computer. You didn't really have to know a whole lot about BASIC to be able to run programs under it. You don't really need to know anything about Python. You just need to have it installed. We have a folder called volumes. Whoops. Okay, we'll cover printers first. There's a folder called printer, and inside it has a data file called print out. And what this is, for example, from the TRS-NET, I did a directory and told it to print that directory. The print jobs are now redirected over the network. It will place your printouts in print out. There's things that could be done in the future to each time start a new file. You would have to send some type of terminating character to tell it to close one file and open the next one. But for right now, we can put it all in one file. And if you decide that, you have a lot of print, you can just copy and take the part you want each time. You could, use your regular editing, notepad editing features to get the data out from the printout that you want, leaving anything else behind. You could also just delete the file and get a new one. When it starts printing, it'll print a new one, create a new file. So there's a lot of different options there, and the code could be modified in the future. That at the end of a print job, it maybe sends a null character telling it to skip to a new file. Lots of possibilities there. So now we'll talk about volumes. All of these volumes right here were created using MySosis disk utility. And disk allows you to create a file that acts like a disk drive, can be mounted to act like a disk drive and appear as a disk drive. And the contents of the file will be binarily equivalent to an actual 720K or 360K. And the reasoning behind that was they could use disk copy. You had a file that represented a 720K floppy. You could be using that file on your hard drive at high speed, but when you wanted to take a backup of it, you could mount that disk image as a drive, put a floppy in another drive, and use disk copy and just copy floppy to floppy. So in our default, we use SYS 720K, which is what I'm saying here. It's a systems disk. The size is 720K. That's the way I created you could call this file anything you wanted. That just reminds me. I used the disk and created the SYS 12M, so it's 1.2 megabyte, 8-inch floppy. You can even go up to, I think, 96 cylinders on that in disk. It'll let you create one that's non-standard with even more cylinders, even more storage. But using just the standard defaults, what is it, 77 cylinders on an 8-inch, 1.2 meg, it works fine. My software seems to handle all the different disk folder files, if they're 5 1/4, 180, 360, 720K. 720K single-sided, making it back to 360, but yet we tell it has 80 cylinders, you know. Anything I want to seem to throw at it, TRS-OS handles it okay. But I am having trouble with the GP2000 correctly handling the 1.2 megabytes. That could be my fault. I'm not blaming their program. I need to research it more, but I've hit a roadblock on that it doesn't really seem to be working correctly for me. And there again, that could be my... Let's go ahead and we're going to, as part of this demo, use the GP2000 program. And we want to, you know, it's a great little program. Want to give credit to them again. There's their about. So you can find this on the internet. Great program. I'm well aware of how much work it took to do something like this and the technical expertise. So they're marrying, they're emulating the hardware there. I'm lucky. I had it easy. I'm just doing the operating system. So a big hats off to that once again. All right. So now that we have installed TRS-OS and we have that running here, and we have our emulator. I just brought up GP2000 over here. We're going to enable on the GP2000 drive 3. Okay, that has enabled that drive slot. Now let's mount a floppy. And we're going to insert. We'll come over here and go to our desktop. That's where this folder's at, right? And we have TRS-NET, and inside TRS-NET are volumes, and we're going to mount the SYS 720K. This is the default. That'll be a little more important later. You'll understand why it's the default. So now the GP2000, if I do a directory on 3, we'll see that this file right here, the SYS 720K, that's in the folder of volumes, that it has files. And importantly, one of the files it has is net echo, net ping, and net stats. All right, moving along. Now that we have that up and running, let's launch our TRS-NET. All I need to do is click on it since Python's installed on my PC. And I'm going to size that box down a little bit. We can now close this folder for TRS-NET. All right, we bring up the TRS-NET Python, enter path or enter for the default. The default is the volumes directory. So it's running from this folder that we created, and in this folder is a folder called volumes. So I'm just going to go with that default. Then it wants to know which data file. The SYS 720K that's in the volumes folder is the default. We're just going to take that. Now, different systems are going to be running at different baud rates on their UART. The F91 series from Circle M would be 115,200 baud. The F92 series would be 230,000, which is option 10. I'm running on a development system, and my ports are all set for 230. I have experimented at much higher baud rates, by the way. So we're going to pick 10. Now here's the tricky part. It lists the serial ports. Again, I wrote this code, not real good at it. But let's see. If I remember correctly, I want port 4. Let's try that. Okay, now the server is up and running. And on this main screen, we have an identification of the program. Tells the COM port, etc. Our directories and the files it's using, where it's sending the printout.txt. Our statistics here for the server, what's happening. Alright, so now I need to launch TerraTerm so I can connect to my development system. So I launched TerraTerm, and I already had TerraTerm set up for COM port 5, 230 kilobytes. TRS-OS was already loaded and ready to run. It was just waiting on receiving a clear to send. But I'll tell you what we're going to do. Let's just start that from the beginning. I'm going to go back here to the development system. And let's start TRS-OS from the very beginning. It'll take just a second to load and run here. I always put a little, so I'll know when that screen changes, because there you go. So it's pinging the server, no reply to ping. What's happened to my server program? It's not even here anymore. What happened? Wow. Let's launch it again. We're doing our first troubleshooting. Honestly, I never have any trouble with this. I assume it's just being stubborn. Honestly, the TRS-NET program, I have less problems with it than any of the rest of the software I'm using here. Okay. We're already up and running on TRS-OS, which is what loads TRS-DOS and runs it. But if we notice here, we have the letter N for network utilities and tests. I'm going to hit the letter N on my keyboard, and here it lists the network, and there is no volume name. There is no, if you look down through here, there's no hex values in there. The drive code table +3, the drive code table +4, current cylinder, max cylinder, etc. It's all empty. So the first thing I'm going to do here is to hit the letter Q for query. And again, if we talked about, I said we'd talk more about it later. Over here on the right, in this disk files is a command now that TRS-DOS has, a command called net. Oops, sorry, disregard. I'm saying that. I'm on the wrong subject. I'm going to hit Q for query. If we look at the statistics here now on our server page, it tells me that here on the left screen, it'll tell me that it sent the query, waiting for the server to reply. The server did reply, and press enter to continue. Let's press enter. Now we can see all these fields are filled in. Over here on the server, we can see that it's been commanded to read the header, sent a control signal, then told to read the header. Simple enough. Reading the header provided the parameters of this disk drive that's mounted. Now, the next thing we want to do is bind. We want to bind this client to the server that we just found, but with our query. I'm going to hit the letter B. It is now bound. If we look over here again on our statistics for the server, we can see it's received a bind command. That makes its second control sequence. It's still only received one read header. You're probably only going to have that one time during boot up, and that's it. Unless you change your server volume and you query it again, then you'll have another read header. Okay, so now we're bound. This client is now bound to that server that has a volume mounted with these parameters. Simple enough, right? While we're here, if we thought we were having some problems with the network, we could hit E, echo, and that sends a 256 byte packet out and sends it back. And I want to point out that there's error detection and correction. It took me a while to write that. There's a checksum going on, So it would know it if these didn't match. And not only does it compare the packets, but there's a checksum also. So we could use an echo, we could use a ping to make sure it's still out there, you know, maybe you're troubleshooting. The letter S, and that brings back this netstack command here on the right. If you was at the TRS-DOS ready, you could type netstats, or here in this IPL menu, we could hit the letter S for stats. If you notice, each time here on the server, it receives a control sequence. That's incrementing, 10, 11, 12, 13. The stats at the bottom is also incrementing. We've hit stats 10 times. What's happening here is we can't update the statistic page every time we do an I/O on the network, because we would spend all of our time updating the screen. So instead, sometimes it updates with different control sequences it received, but more importantly, you can force it by typing netstats at the command prompt. Okay, so over here on the left, I'm going to hit escape and come back to the main screen of TRS-OS. Volume 6 is the network volume, will always be the network volume. We can now see a volume name, LFF1 sys, and a date that was created, I think is the creation date. It's a disk, and its size in bytes, 737,536. That's a 720K. Okay, so I'm going to press 0 now, and the system will boot up as normal. If I do a directory of drive 6, you notice it's the same as the files on the right. Now, let's say that I build dan/text on drive 6. And I come over to I look at drive 3. It doesn't show up. Whereas on the left, it's still there. We have a dan.txt at the top, but on the one on the right, on the GP2000, it does not have that. So we'll do something here. Let's replace that disk maybe. Yeah, it still doesn't show up. So something is happening with the buffering and or caching. We're going to build one from the other side. Build test. Put something in there. Close that file. Now if we look from neither one is showing up. But this bug seems to be because there's some caching happen, and it's only reading the cache once. I've got to find out how to flush that. Right now, this is very useful for if you have some files on one system and you want to get them over to the other. But it can have some unreliabilities in that once it reads the directory, it doesn't want to seem to go out and read that again. So we have to keep working through that. over here and do a free on, what was it, drive 3. So you would have thought that that in itself would make it read the directory again. We have a long pause here. There's a couple of things that we have to work out, but it doesn't want to show once you boot up. It boots up fine. It's a good way to get files from one system to the other system. But after it does that, there seems to be some caching going on that I'm going to have to figure out how to flush on each side, so it forces it to go back and read again. I think this is more the fault of Python than it is the GP2000. I believe that the Python is running a cache or a buffer or both between the two systems. So that's the one bug I know of. I can just tell you now, if you reboot these, it will find the files on each side. Let's try that. Watch it make a liar out of me. Let's reset this one. We're wanting to see if it'll come up and find... Now what have I done? Have the... Sorry I had to pause for a minute, but I had to restart the system because I had the wrong floppy for the boot floppy mounted and the emulator diskette for drive 0. That was simply because before I did the video I was working on something else. I don't pre-rehearse these videos. I probably should, but it's already a pretty big effort for me to do what I'm doing now. I have some health issues. So anyway, we have a little bit to work out here. This, you can plainly see that it stores the files. After I rebooted the server, now we can see that the test shows up on both sides. On the emulator, we have test here, and on the TRS-OS side for drive 6, we have the test file. So I believe that this is all in Python, that when I'm writing to the disk, it's not forcing it to physically write at that moment, but it's caching it or buffering it, and the same on the reads. If we're telling it to read from the file and it has just recently read those records, I don't think it's forcing it to read again. It needs to, because maybe another system like the emulator over here had changed something on the disk, so it doesn't realize that. It's just still pulling from a cache. I have some things to work out there, but it's great in that right now, if I need to get some files from the emulator over to TRS-OS or TRS-OS over to the emulator, I can put them on the one common shared disk file that's shared between them. I can do that. So this is how you install it. This is how you boot it up and run it. We're going to be researching what's happening here with, I believe it's the Python side that's buffering and caching and causing the data to not be available to both at the same time. When you change on one, it automatically shows on the other. In the past, I had some ways that I was forcing it to, and at the moment I can't remember what I did, but I have worked it out before that I could. I was thinking it was simply because I rebooted, but we can't be rebooting all the time. So let's, real quickly here, do a directory, and we're going to tell it to print that directory. I can see here that my lights are flashing on my development system, and so that tells me that it's outputting data. If I go in to my printer folder now, remember we deleted the file. This shows at 6:37. This is the correct date and time just now. We created a new file again, and it now has the directory that we just sent it using the print command. All of that seems to work really well. I haven't found any problems with the printer. But I was kind of wondering, how much data did I have to transfer? So again, we could close this. We could rename this file, delete it, or just leave it, and the next printout will append to this one. You can go in and copy and paste just the data you wanted out of it. But let's take a look real quick. I told you there were some new commands on our PC. And they were over here on the right: netstat, netbind, netstat, netecho, and netping. And these are going to do, we can see here from the last print job we did, there's the characters that it printed. I'm restarting. So 3,470 bytes was received for printing. And that held the entire print job we just sent over there. Let's try a couple of those commands. Say we think we're having trouble. Maybe the connection is getting garbage, we think, possibly. And so if we echo a packet of 256 bytes over and back, here it tells us that it's commanding the server. It's sending the packet, echo packet sent, waiting for the server, received a packet, comparing the two packets, and then it passed. And the echo command is done. So you have some reasonable expectation that you must be running you have an error, you're transferring data without error. If we just wanted to know if the server was over there, we could just do netping. And that's not really transferring much data, but it does command the server to speak, and the server speaks and finds out it's there. And then we have netstats. And remember, I told you that statistics on the server is not updated on every I/O because of the time that would cause. However, we can type netstats, and we saw a little blink of the server screen that forced it to update all of its statistical data on the screen. Okay, sorry, hope this helped. Again, sorry I don't lay these videos out better. You kind of get them as they come here. You see the problems that we have, which really isn't a whole lot. It's nothing you can't solve. Maybe a reboot here, or making sure you have the right file mounted there. But it all works pretty good. I'd be happy to hear any comments or questions you may have. This is on Facebook, www.trisdos.com. Be happy to have you there. Otherwise, I hope you enjoyed this video.